You are welcome to gases in the mine environment. Like from the previous lecture, we understood that when you come to the mine environment, you have several gases. The mine air is not like the atmospheric air that has its own concentration of various gases. The mine has different operations that goes on, and due to that, there are different gases that are released into such an environment, which is a confined space, not the whole of the atmosphere. And because there are several gases that are released into that environment, there are a combination of gases, and sometimes the reaction of from different gases can cause problems. We have methane gas, sulfide gas, we have carbon monoxide, we have carbon dioxide, several of the gases that we have spoken about. For this lecture, I'm going to start with one of the gases, which is the carbon monoxide. Carbon monoxide gas, it constitutes one of the greatest hazards to life in the mining environment. The reason being that this gas, usually you cannot smell it, you cannot taste it, you cannot see it. And they are in the environment. And so if you do not find a way of detecting these gases in the mine environment, it can cause havoc. And then again, if you do not even know the concentration of this gas, it can have an effect on you because you will not know how much you are inhaling into your system. It is dangerous unless adequate ventilation is provided. And so when you're working in an environment, a mine environment, which has poor ventilation, and you do not have a monitor to check the carbon monoxide in that environment, there would be a problem. Again, even if you check the concentration of this carbon monoxide and you have poor ventilation, it can still have an effect on you. And so to prevent all this effect from carbon monoxide, the best thing is to have an adequate ventilation in that environment. And mind you, the kind of ventilation you have, either you are trying to flush out the air in that environment, you still have to look at the weather parameters, the parameters like humidity. Sometimes this humidity, if you have high humidity, you don't even get these gases dispersing out. They are concentrated in an environment. So you have to look at all these parameters, the temperature of the environment you are working in. They all have or contribute to the negative effects of these gases. And so ventilation is very important. One thing we also have to understand is at what point can we say this carbon monoxide will explode if ignited? Carbon monoxide will burn an air that contains 12.5 to 75% of carbon monoxide. It will explode if ignited. What it means is that carbon monoxide can be in that environment, but it will not explode because there is the condition that has to aid explosion is not available, like the oxygen, like the ignition source. If we don't have that, explosion might not occur. However, the concentrations might affect the health of the person if inhaled in certain quantities. We still have to know the specific gravity of the gas, which in this case, the carbon monoxide gas. The specific gravity, which is the density, is 0.967. And why do we have to understand it? We have to understand it to understand if compared to oxygen, if the gas is going to be at the bottom where everyone works or to be above everyone. Oxygen is 1. And so if oxygen is 1, for instance, it means that it is heavier than the carbon monoxide. So to give us an idea which part of the room we would have that gas. Again, the ignition temperature is 609 degrees Celsius. This is the temperature that would cause is the ignition source. And so if every condition plus the ignition temperature, the concentration of the gas, and then source of that is fuel, that is the oxygen is also available, we expect explosion. We need to understand all these parameters, the parameters of these gases, for us to know what to do at what particular time. You know your operation would generate carbon monoxide. And so if you understand that you have this gas in your environment, then you would have to monitor all the parameters that can cause explosion. Carbon monoxide in excess of 0.01% in air may eventually produce symptoms of poisoning. What does it mean? 0.01% in the air. Symptoms of, meaning if you have this amount of carbon monoxide and you inhale it in your system, symptoms like headache, shortness of breath, dizziness, unconsciousness, all of them are the symptoms of poisoning, meaning you have inhaled. And you have to understand that some of the symptoms, it can be acute or chronic, can be immediate effects. And in those conditions, like we said, you have to keep the place very ventilated. And mind you, you are going to be in that environment for some time. If you're going to be in that environment for an extended time, the concentration can be very low, but the extended time you spend in that environment could also have an effect on you. Now we said if you have 0.01% in the air that you breathe, it can give you symptoms of poisoning. Now, what about 0.02? It means that the concentration has increased. It will produce slight symptoms after several hours of exposure. What this is saying is that you cannot depend on only the concentration to think that you are safe in an environment. The concentration can be small, but if you are in that environment for a very long time, then it can have an effect on you. The concentration will be small, but when you are in that environment for a very short period of time, it means that it will not have an effect on you. Again, if you look at 400 ppm, which is 0.04, exposure for 2 to 3 hours, you have headache and discomfort. 2 to 3 hours, you have headache and discomfort. They are all the symptoms of the poisoning. So the time, the duration is very important. With moderate exercise, with 0.01% carbon monoxide. Now, we have talked about concentration, and we have talked about extensive time or several hours of exposure. They are all contributing factors if you would get the carbon monoxide saturated in your system. But we are saying that now, if you have moderate exercise, you exercise. There are some people who will be at rest. Let's take a mine environment where there are people who are seated in the office. They are usually not very active, but people on the field, they exercise, they are very active. What does it mean? What it means is that those who are very active, they need more of the air in their system. And so if you have with moderate exercise, with a concentration of 0.12% of carbon monoxide, what do we get? You get slight palpitation of the heart in 30 minutes. Somebody who is at rest within this 30 minutes, will not have effect because the person is at rest. The amount of gases that the person inhales is limited. It's just like somebody running. You are running, you will need more oxygen. You'll be breathing in more. And so that same way, if there's some form of exercise, you would breathe in more of the gas than the person who is at rest. And then if it goes to 1.5 or 1.5 hours with that same concentration of 0.12%, what happened? There's a tendency of stagger, like somebody who is drunk, sort of. That is how it is. But then if you go to exposure is about 2 hours, what it means is that you have confusion of mind, headache, nausea, all these things come into play. So the duration is very important. The concentration is very important, as well as if the person is at rest or not. And so if you know your workforce, you can understand how long the person can stay there, or the kind of amount of gases that should be released in that environment or not. They are all very important things that we should look at. If you look at in concentration of 1.2 to 0.25%, unconsciousness usually occurs in about 30 minutes. You get unconscious. And if you are still in that environment, it can be fatal. What it means is that at that point, you have to find a way of taking the victim out of that environment, which is very important. You have to take the victim out of that environment. Otherwise, continuous stay in that environment beyond the 30 minutes would only get fatal. Again, a maximum of 0.05% or 50 ppm carbon monoxide for 8-hour work shifts. That is the maximum amount. What this means is that for you to go through your 8 hours per shift, for your entire period you are going to work in that environment, so you go on pension. If the concentration of carbon monoxide in that environment is 0.005%, then it means you are safe. That is the maximum that should be allowed. It can be low. So you would see people who would take everybody's shifts because it comes with extra money. What you are doing to yourself is, like we said, the duration is very important, the concentration. So though the concentration in that environment is 0.005 or less, because you are doing an extensive number of hours, you can still be affected. Some people go on pension before the sicknesses start to manifest. You are out of your work on pension before and you'll be wondering, the concentration there was always small. It was the concentration that needed for me to stay alive. But then, why am I getting this complication? Why am I experiencing these symptoms of poisoning? It is because the concentration is right, but the exposure time is not. Now, let's look at how this CO2 acts when we breathe in air. So we look at the relationship between oxygen and hemoglobin. And then we look at the carbon monoxide and hemoglobin. What we have to understand is that in the blood, when we breathe in, oxygen attaches to what we call the hemoglobin in the blood, so that the blood with the oxygen will move to all the tissues that need oxygen to function. So we call oxyhemoglobin. That is the ideal thing that needs to be done. We breathe in air, the oxygen attaches to the hemoglobin, and then in the blood, it moves to all the tissues that need the oxygen and releases the oxygen in those places. But what the problem is that the hemoglobin form a stable compound with carbon monoxide. In simple terms, it has higher affinity, meaning Hemoglobin will choose carbon monoxide over oxygen. And so when you're in an environment, there's some amount of oxygen and then some amount of carbon monoxide. The hemoglobin will rather attach to the carbon monoxide. And its affinity is about 200 to 300 times higher than oxygen. And so in that environment, no matter what you do, your hemoglobin will attach to the carbon monoxide, meaning the tissues that need oxygen will be deprived of those oxygen. That is why you start palpitation, you start feeling dizzy, sometimes you go unconscious. It is because oxygen is not being able to get to the places that needs it, because oxygen is not getting attached to the hemoglobin. So the interference with the oxygen supply to the tissues produces symptoms of the carbon monoxide poisoning. That's the symptoms. All the symptoms I've mentioned: unconsciousness, dizziness, confusion, all of them, staggering, all of them would you start manifesting because oxygen is not able to get to those places. So the same thing parallel the extent of blood saturation. Yes, the amount of carbon monoxide in your blood, the saturation, how much they are. Maybe the concentration in the environment is so small. So hemoglobin is still able to take oxygen and take carbon monoxide at the same time, but then the levels are such that oxygens to all the tissues are still delivered. But if the carbon monoxide in the environment is so much, then we don't get the oxygen going to the tissues too. So the saturation is parallel to the symptom. If it is high, you get symptoms close to unconsciousness and then fatal. And then if it's very low, we can get the headaches that when you move out of the place immediately, you'll be fine. Sometimes you get unconscious, you have to even be helped with extra oxygen to be able to survive in that environment. Now, severity of symptoms depend on, I have mentioned all of them, but this is what I've listed again. The concentration of the gas is very important. So the severity, the extent to which the person is exercising. The person is exercising, the person needs more oxygen. The victim's health, individual susceptibility, how easily. We are all different. Both of us, two of us can be in an environment, and the carbon monoxide may affect me more than the other person because it's individually based. Then the temperature of the environment, is it going to help spread the carbon monoxide, or the humidity is so high that it will concentrate just in that environment, it will not move, or the air movement. All these parameters help to determine how severe these symptoms of poisoning would be. So it is very important to look at all this. That is why you come from leave, they tell you to go back to the hospital to go and do some tests before you come back to the field. They want to understand how fit you are. Your health is very important. These are some of the reasons. Sometimes they tell you to do it, but the explanation behind it is not in full details. These are some of the reasons why you would be asked to go back to the hospital if you come back from leave. Now, we said this is an experiment conducted by the United States Bureau of Mines. When somebody is at rest, no exercise, rest, the person is just there at the office, not doing any very active thing, rest. What will be the symptoms? So now a percentage of blood saturation between 0 to 10. When we looked at one, we said when somebody had moderate exercise, we said 0.12 has an effect on the person based on duration. We even mentioned that from 2 to 3 hours, we could have unconsciousness. But this one, the person is at rest, no exercise. Concentration between 0 to 10, that is ppm. That is none, there's no symptoms. 10 to 20, tightness across forehead, possible headache. So based on the previous parameters, health-wise, exercise, all those ones can have, it can contribute to what you feel. So these are the percentage of blood saturation. We said it. The symptoms are parallel to the blood saturation. So if you even look at between 40 to 50, same as 30 to 40, with some possibility of fainting, collapse, increased pulse, and then respiration problems. So that is what we are saying, that saturation is parallel to the symptoms. If you have a concentration of between 70 to 80, have very weak pulse, slowed respiration, respiratory failure, and death. And death, some will die immediately, others it will take time. Also, all depending on the individual and all the other parameters that have been mentioned. Now, if you look at how the treatment for CO2 poisoning, how do we treat it? The steps for effective treatment of CO2 poisoning are as follows. Move the victim to fresh air as soon as possible. Why? Because of the affinity of carbon monoxide to hemoglobin, meaning the oxygen is not getting to places that they are supposed to get to. So when you move the person for fresh air, then the person can now inhale oxygen that would attach to the hemoglobin and move it to the places that needs to. Then, if respiration has stopped, is weak or intermittent, or present only in occasional gaps, give artificial respiration. Just like you'll be giving oxygen in the hospitals. Give something that will aid in the respiration. Some of them cannot breathe anymore because of the amount of or saturated blood. Administer pure oxygen. We have some non-rebreathable mask that you would get in. So if you breathe it out, it's not the same thing that will come out. That is also very important. And in this thing, at least 20 minutes in mild cases, as long as 1 or 2 hours in severe cases. This is the reason why we always have to get first aiders on site. Because sometimes it can happen if you have no idea, the person might die. First aiders on site is very important. Aid circulation by rubbing the patient's limbs towards the heart. So now, if you do it away from the heart, it's also a problem. Away from the heart, we are trying to get oxygen to the heart. So you massage the limbs like that. Keep the victim warm with blankets, hot water bottles, etc. Just keep the person warm. It's very important. Keep the victim lying down to avoid strain on the heart. These are ways of treating this poisoning. Now, let's look at how the physiological effects of carbon monoxide, that is on us, our physical health. How is it going to affect us? This time, it is general, it's not at rest. The previous table we looked at, it was someone at rest. Here, that is the basic thing we have to do for employees. So if you have ppm 0.05, that is what we said is the maximum allowable, meaning it can be less. For the maximum allowable, it's allowable for exposure of several hours. Like I said, you can work 8 hours for the rest of your life and it will not have an effect on you. Now, if you have 0.04 to 0.05, can be held for 1 hour without appreciable effect. Now, they've said 1 hour. What does it mean? What it means is that you work in an environment and you know that the concentration of carbon monoxide in that environment is 0.04. What it means is you work there for 1 hour and leave that scene for about 2 hours and come back. And then you can do that 4 times in the day. 4 times, because we are supposed to be working 4 hours. 8 hours, 4 times without appreciable effect. So if you know that, you have to do that. And then noticeable effect after 1 hour exposure. That is when you have concentration of 0.06 to 0.07. Now, if you have concentration of 0.4 or more, death in less than 1 hour. Death in less than 1 hour. So at that point, when you find someone in that condition, all the treatment that we have, you have to first move that person out of that environment and give the person oxygen. If you have to rub the limbs, you rub the limbs towards the heart. You have to do all that. And whilst we are doing it, we are calling for assistance. The hospital, the first aiders will do it, then you have to send the person to the hospital. Now, that is one type of gas that we find in the mine environment. Another one we find in the mine environment is the oxides of nitrogen. The oxides of nitrogen are formed in the mines. So all the gases we are saying, they are formed in the mines. By how? By burning of explosives. And then to a lesser extent, by their detonation. When detonation, they are a form of explosives that are faster than the sound of, faster than sound. Very, very fast. It comes with flames. When it comes with flames, we expect that the oxides would also come with it. And we are saying that burning of explosives. You know, I've mentioned the types of dams. There are certain explosives that happen because of reactions of certain gases. They have ignition source, they have the oxygen. Those explosions can come with these oxides. How do we detect these oxides? Because from our previous lecture, we have mentioned gases that are odorless, tasteless. You cannot see them. You cannot see them. And so you cannot even smell them. You cannot taste them. But there are ways that we can look at or how to detect them. First, the burnt powder odor, familiar to blasters, those who do the blasting. That scent, burnt powder, is familiar with those people. So as soon as they start smelling that, they know these oxides are in the environment. The reddish color of nitrogen oxide fumes. So it means nitrogen oxides have reddish color. Diesel engines also produce oxides of nitrogen. When you come to the mine, they use all these engines a lot. And so you just have to know that these engines releases these oxides of nitrogen. Then gas collected from the burning of 40% gelatin dynamite is also explosive, which contains 11.9% oxides of nitrogen. So if you are burning this 40% of this dynamite, we expect that 11.9% oxide will be released from it. So these are the calculations. You know that, okay, when we burn this, this is what we are supposed to be getting at the end of the day. So these are ways that we can detect these gases. It is very important. Now, these gases, if we do not find ways of detecting it, it gives us, or it brings a whole lot of problems to us. Why? From what we have said already, these gases, because you cannot detect them, if you don't have a way of detecting them, then they become poisonous symptoms. You now start experiencing these poisonous symptoms. Now let's look at what the physiological effects of these gases have on us. Now, if you look at this, it still comes to concentration and duration as well. For this oxide, 0.0005 is the maximum allowable. But if you look at carbon monoxide, it's 0.005. So this one, very small quantities is enough to cause trouble. If it goes beyond this 0.005, it is enough to cause trouble. Like I said, the maximum allowable allows you to work for 8 hours in your shift for the rest of your life and you'll be fine. However, if you have extended exposure of the same concentration that at 8 hours, it is fine. If you have exposure beyond these 8 hours, then it starts accumulating. The saturation in the blood will start increasing. So if you look at 0.006, minimum causing immediate throat itching, and then we have the concentration of 0.02 to 0.27, rapidly fatal for short exposures, very short exposures. We have places that like confined spaces. Confined spaces, if these gases are there, you have to work with caution. You have to work with caution. I remember when there was Atuabo gas pipeline, people died in it. Is it that the exposure was too long, or is it the concentration of the gases that were in there? So all of them they combine to give us the problem we face. So let's look. A person exposed to dangerous concentrations of nitrogen dioxide or this oxide may result in no discomfort or for several hours after the exposure. I know now you know why, that you can even have dangerous concentration, but you might not have any discomfort of several after the exposure because of all the parameters we have talked about when it comes to how we get the blood saturated. Some of them is the health-wise, maybe there's good, the temperature, so it's able to spread. Sometimes we look at the specific density, we know where the concentration will be. We look at the humidity. All these things contribute to if the exposures are going to be fatal or not, or they are going to give us any symptoms of any kind of poisoning. So you cannot say that because the concentrations are high in a certain environment, that is the end, you are going to die. It depends on the exposure. It depends on the person in there. Or sometimes they are said that you don't feel any discomfort until you get to the end where there's going to be a problem. Like I said, all these parameters can also influence that. As much as 8 hours after exposure, the victim's lung may become filled with fluid resulting in asphyxiation. That means, yes, you might not feel uncomfortable or any discomfort. You don't feel anything. But after this prolonged hours, this is what you feel. Your lungs, which helps in breathing, become filled with water. What does it mean? You will not be able to breathe. You will struggle to breathe. That is the asphyxiation. That is one of the signs. Sometimes you get to a point, you don't feel anything, but it happens all of a sudden. It happens all of the time. So air samples analyzed for oxides of nitrogen are reported in terms of nitrogen dioxide. Why? It gives proper evaluation of the toxic properties of the atmosphere. So that is how we measure it. Nitrogen dioxide, and we know the negative impact they have. The threshold limit value of oxides of nitrogen is 5 ppm. Threshold value, it means that the maximum amount of this oxides of nitrogen that you can take and be okay. We have seen the physiological effects already, and we said 0.0005. That is the amount that if we take, we will be okay without going to the hospital. So this is one, there's other type of gas that has an effect on us. And so we have to put all the monitoring systems in place. All the monitoring system, whichever source we can get this nitrogen or oxides of nitrogen, we have to find a way of ensuring that all the people that work in the environment are safe. If you know the concentrations are going to be high, what it means is that you have to reduce the exposure. So people can be in the same environment, reduced exposure, but the one person can now start exhibiting the symptoms of the poisoning. Why? Because of the individuality. The health-wise, the person is exercising, the person is at rest, all of them contribute to it. Now we look at another type of gas that we find in the mine environment, and which is, it is the sulfur dioxide. It is produced by burning sulfide ores like pyrite, or by blasting in sulfide ores or explosion of sulfur or dust. All we see is that where there is sulfur, is it the ore or blasting, you go to, you go into the mines, and they need to blast to get the mineral of interest. But the place they are blasting, there's sulfide there, the ore there is sulfide. That can produce this sulfur dioxide. Some diesel fuels also produce this sulfur dioxide. So in this case, you have to ensure that all these diesel fuels or engines that are emitting this kind of gases, they are in places that are well ventilated. You cannot go and park these diesel engines in an enclosed place and keep it running. When you keep it running, what it means is that you don't get fresh air coming into that environment or that room that you have locked. You can't ventilate the place very well, and so the gases remain there. Especially if we have high humidity. What does it mean? It does not allow even the gases to move freely. It can concentrate at one place. That is why you hear in the news, a family of 5 died in their sleep because they left the generator on and it was locked in the house. Maybe they left it in the garage and it was running. The carbon monoxide can kill them. Like, that and other gases can kill them because we don't taste it, we don't smell it. Some of them, we do smell it. Some of them smell like rotten eggs, but at elevated concentration, it paralyzes the reaction. It paralyzes you that you can't even smell it, the elevated concentration. So with these diesel fuels that are used in your operation, you have to ensure that they are at a place that is well ventilated. This gas has a strong sulfur smell, which is suffocating and very irritating to breath. Unlike other ones that you cannot smell anything, this particular one, it smells like sulfur, very high. The gas affects the lungs, same manner as the oxide of nitrogen. How is it? The oxides of nitrogen, it fills your lungs. Fluid fills your lungs. So when it fills your lung asphyxiation, you cannot breathe. You struggle to breathe. At a point, you might not be able to breathe at all. So it behaves just like the sulfur behaves just like the nitrogen oxides. So we have to be very particular about that. Now let's look at the physiological effect of these gases. The threshold values are very important. And I have said it, repeated it. The threshold values are important because they are the maximum allowable for an 8-hour day. Usually that is how long we should work. But if you go onto the mines and people work more than that, and people can work continuous 13 hours and all that because it comes with extra money. But your health should also be very important. You don't want to go on pension and use all your money to attend a hospital. It's very important. Hydrogen sulfide is another one of them. Even before I even talk about hydrogen sulfide, one thing you have to know about the sulfur dioxide is that it is highly soluble in water. In fact, it is one of the most soluble gases found in the mines. What does it mean? Depending on the sources, there are certain areas, maybe in the rocks, that has water. If you don't disturb it, it is there in the water. Unless we go there to go and do drilling, go and do blasting, then we release it out of the water into the environment. It's a very heavy gas and has specific density of 2.269. What does it mean? It is heavier than air. And so when you have sulfur dioxide in that environment, we expect that it should be at the area where people work. That is the area we find this sulfur dioxide. And it's colorless, so you might not know by the smell. Because it has this strong sulfur smell, you might know about it because of the smell. But the fact that it is in water, you don't disturb it, it is there. So usually these gases, when they are in their natural state, they don't have a problem. Some, like the sulfur dioxide, we said that in all rock samples, if the rock sample is not disturbed, the gases are there without any problem. So you go there to go and blast. And then in the mine environment, you would still need to blast to get your mineral of interest. So it is a necessary evil that you go and touch it. However, when you do it, you have to monitor the concentration and as much as the exposure time that you need for you to be in that environment. It's very important. Now, you go to the next gas, which is the hydrogen sulfide. Hydrogen sulfide is one of the most poisonous gases. It's very poisonous. Only traces of it are ordinarily found in the mine operations. It means that we don't have a lot of hydrogen sulfide in there, but traces. But we still have to understand that it's one of the most poisonous gases. And so even if we find traces in there, it should give us reason to be cautious about their concentration. In low concentration, its distinctive rotten egg odor is noticeable. In high concentrations, the sense of smell is quickly paralyzed by the action of gas on the respiratory system. What it means is that higher concentrations, the way you can smell it, that sense, it's completely numbed. You cannot smell it. Higher concentrations, but low concentrations, you will know the rotting egg. Meaning, we are saying that it is very poisonous. When they are in very low concentration, we can smell it. But if you enter an environment where there is high concentration, your senses are quickly numbed, they are collapsed, so you cannot smell it, which makes it very dangerous. Because at least if you smell it, you will know that that gas is in that environment. But if you do not smell it, it can do whatever it has to do. Because if you don't detect it, maybe you don't have a monitor. Of course, the mines will put all those things in place. But if you are working in an environment and you realize that there are no, these gas detectors, monitors are not available, you should ask your supervisor, at least you know that these gases are going to be in the environment so that you can monitor it. When you monitor it, it gives you an idea if you have to stay in that environment for long or for short period. The gas has specific gravity of 1.176 CV and may collect at low points in the mine. Why? Because they are heavier than oxygen. It is heavier than oxygen. So all those that are heavy, they will come down. And so when they are down, you don't have enough oxygen to breathe. That is where the problem starts. The ignition temperature of hydrogen sulfide is 260 degrees Celsius. That is it. Now, we will look at the physiological effects. But the hydrogen sulfide inhaled in a sufficiently high concentration produces immediate asphyxiation. Why? Look at the specific density. It's very high. It's higher than, so it will come down to room where people were ground level that you need oxygen to breathe. Asphyxiation, because you will struggle to breathe. That is when they are in high concentration. In low concentration, it produces inflammation of the eyes. Though we would get that rotting scent, at least if you start smelling, you should know what it is. In low concentrations, you have the inflammation of the eyes and respiratory tract, and sometimes leads to bronchitis, pneumonia, edema of the lungs. It means that even in low concentration, like we said, it's very poisonous. They have serious effects on us. Pneumonia kills. All this, they kill. You struggle to breathe because they are affecting your lungs. And if there's something that is affecting your lung, it affects the way you breathe. You cannot breathe well. If you have any fluids collecting in your lungs or any dust settling on your lungs, means you cannot breathe well. So these concentrations, even if they are in low concentrations, they still have an effect on you. So some of the gases that are, their specific density are lower than oxygen, means that they will be above us. So areas where we are supposed to be breathing, we get the oxygen and breathe. But those that are heavier, you need to pay attention to those ones. The immediate effect of hydrogen sulfide is extreme irritation to the eyes. We have said it. In low concentration, you have extreme irritation to the eyes. So the concentration will tell you. The concentrations will tell you if you have 0.001, that's the maximum allowable. But if you have 0.1 to 0.2, that one in minutes you can go unconscious or death immediately. And that also depends on your health. So the concentrations are important, as well as the time, the person involved, and all that. Very important to look at. Now, where are all these gases coming from? Based on where they are coming from, we can classify them based on their source, where they are coming from. Because we have mentioned several gases. We've even mentioned methane already. All this, we've mentioned carbon monoxide. All these gases in the mine environment, what are the sources? And even from the lecture, I have mentioned that some of them, like the sulfur dioxide from sulfur ore, I have mentioned that some of the sulfur, they dissolve in water. So when they're in water, they are okay, no problem. So on the mind, what are the sources? So based on the sources, we have the strata gases based on the sources. Then we have gases from the mining activity, metal recovery, and other industrial operations. From mechanical, electrical, renewable. From your own operations, we can get some of these gases coming from it. I remember one renewable energy student gave an example how these gases can come through the kind of engines that you use. All of them. And then another one is gases from unscheduled occurrences. We will look at them. When we talk about strata gases, which of them are we talking about? From your mining activity, from your metal recovery, from your industrial operations. Then unscheduled occurrences. Now let's look at them. Now when we talk about strata gases, look at how it's like a strata, one on top of each other. That is how it is. Have their existence from mineral deposits or formation of nearby rocks. It can be from chemical actions or migrations. These are rocks. Strata, they are more like layers. That is, so the picture here can tell you the source of strata gases. And then the major strata gases are these ones: carbon monoxide, nitrogen, sulfur, methane. All of them are strata gases. But in this strata, would they just start being released? They are strata gases. And so would you just start releasing the gases into the environment just because they are in the rocks and there? Like I've told you, if the rocks are there without any disturbance, you would understand that the gases will remain there. But until you go and disturb it, you don't have any problem. Until you go and disturb it, then we have those gases in the environment. Sometimes it's not just deliberate disturbance, it is because of your operation. You want the mineral of interest in the mine environment. So that is what you have to look at. Now, under these strata gases, we are saying that we have the adsorbed gases. When we say adsorbed, there's adsorbed and absorbed. Adsorbed means it is attached on the surface. It is not inside the sample we are talking about. If it's a rock material, it's not inside. The gases are attached to the rocks. So if you release the pressure, the gases would be left. And how do we release the pressure? When we go down there to go and do blasting, exploration, drilling, all that. That is how we look at it. And then we have fission gases. And we have radioactive gases. Fission gases are just gases that are in cracks, crevices, and all that. And sometimes they hold water. Like I told you, some of the gases, they are soluble in water. And so when you disturb this water, then you release the gases into the atmosphere. Then we have radioactive gases. Now, if you look at the adsorbed gases, physically adsorbed onto the rock surface, like I've said, they're onto the rock surface. Desorption of gas occurs when there is breakage. Desorption is more like you have taken the gas that is attached or onto the surface of the rock, you have separated them. That is desorption of gases. Occur when there is a breakage at the rock surface, that is decrease in pressure. Yes, pressure is supposed to be pushing it down. Now, if you go and start with this drilling, blasting, then you decrease the pressure and to go up. And then the adsorption process is moderate process. That is it. So the basic thing you have to know about absorption, absorbed gases, the basic thing you have to understand is that the absorbed gas, they are attached to the surface of the rock. And if you do not disturb it, they are still on the rock until you disturb it, then you can have it in the mine environment. These are some of the reasons why you will definitely have gases released in the mine environment, and we have to take precautions as to what kind of gas we have in the environment. Then fissure gases, gases that are absorbed in fissures. Now you see the word ab. The first one is add. If you interchange it, you are describing two different things. So you have to take note of that. Dissolved in water, trapped in cracks. If you look at these rocks, they have water and the gases are in there. You don't have a problem until you go and disturb it. In cavities within the rock mass, these are fissure gases. The gases are in those cracks. The water in those cracks. Note that some fissure gases are only soluble in water. In water, that is it. Example is the methane. Some are there under pressure. So they are under pressure. So like I said, until you reduce the pressure, all these gases do not have any place. So the gases in the environment, in the mine environment, are all coming from these sources. Then we have radioactive gases. We know about radioactivity, where we have half-lives, that the gases will break very fast, this radioactive gas. So depending on what you are doing. So radioactivity, that is the radioactive decay, the emission of ionizing radiation, that is energy loss due to nuclear instability. So if the nucleus is very unstable, you have it breaking into different daughters. And all these daughters are coming as a result of this instability. So we have gamma rays, beta rays, all those rays, X-ray, depending on which one the severity is in. We use X-ray for ourselves. We go to the hospital for X-ray. X-ray is able to go into the tissue. So some of the rays, they are not very dangerous, but depending on beta, gamma ray is very dangerous. So what it means is that when you are working in those environments, you have to find a shield. You have to find a shield that will break the ray from getting into you. That is why it is said that when you are working in environments that has some kind of ray, you have to put in extra precaution. I remember when I went to do my attachment with Ghana Atomic Energy, we have to go to the radiator center. With the radiator center, you have to write an exam and pass before you can go there. If you don't pass, you will not be allowed. So you'll be given a book to read for maybe a day, the exams, oral. When you pass, then you go there because they want you to be protected. And all the ladies, we were asked if we were pregnant. The reason being that these radioactive rays can affect the fetus the fetus, can destroy it. So you realize that all the women working there, as soon as they get pregnant, they don't go close to the radiation center. So it is very important, like the radon. It is colorless, odorless, non-flammable, tasteless, noble gas. Insignificant amounts of radiation are exposed to the land. They have long lives. So those that have short life, that will be breaking into different daughters, they are the ones that give a lot of the problem. So it is very important that we look at all these gases wherever you are working. These are the sources of gases. Possibly it might not be in your work environment, but anytime it is in your work environment, you have to put in precautions. That is why it is very important to know your kind of work. The work you are doing, you have to look at that. That is the strata gases that we are talking about. Now, gases from mining, metal recovery, and other industrial operations. The categories we can get from blasting on the mines, diesel engine emissions, gas from metal recovery operations, and other activities. Other activities from your mine, maybe you are cutting some cables, they can also release some gases. So there are different things. Sometimes these gases are coming from even farming activities. Maybe decomposition of certain biodegradables on sites. All of them are gases from other activities. Then we have the other source, which is the gases from unscheduled occurrences, the carbon monoxide, carbon dioxide, sulfur oxides, nitrogen oxides, the fires and explosion during accidents can release gases. You understand that some of the gases, when the conditions are right, we have ignition source, we have fuel, we have the type of gas involved, we can have explosion. And this explosion also brings out gas. And we have talked about the types of dams. The after dams, for instance, after the explosions has happened, there's still some reactions that is going on. And that reaction is able to also release certain gases for or into the mine environment. So all this action you have to understand, because sometimes nobody plans for explosion to happen. But based on the conditions that are available, we can have these gases being released and then explosion occurring. So they are unscheduled occurrences, they are accidents that happen. And this accident releases gas into the environment. So these are the sources of gases we are talking about. The strata, from mining operations, mineral recovery, and then unscheduled occurrences. So all the gases we talk about in the mine environment, they have their own sources from which we get these gases in the environment. So like I have said, these gases, they become poisonous, or the severity is as a result of the saturation in the environment. And so if you have high concentration, it can affect you. It can be chronic, it can be acute. Acute is immediate. But the concentration alone is not enough for you to say, because the concentrations are very low, I can work there as long as I want. No. The exposure or duration of exposure also contribute to the fatality or the severity of this exposure. So these are the gases we find in the environment. I'll end the lecture here and then we will continue again next time.